Example 5 says to consider the data on altitude, latitude, and the temperature in February in the section 4.3 data file. And the first question is asking which variable is a better predictor of the temperature, altitude, or latitude. I don't think there should be a comma there. Get rid of that. There we go. So we're going to relate those and see which one has a higher correlation coefficient. So to do that, I'll take the data and copy and paste it into this one. So the average temperature in February, a bunch of cities there, and copy that. This is our y coordinate. So paste that in there. And then for our x coordinate, let's do altitude first. That one there. And when I do that, I'm looking at the correlation coefficient, which is small. It's close to 0. It's 13.24%. So let me just put those two down. Just going to write this down so we have reference. And then I'm going to switch out the x coordinate and see what the correlation coefficient is. Okay, so switch in this one. Just going to get rid of that one for now and switch it to latitude. And we get a much larger correlation coefficient. And because of that, larger in absolute value, that is. So it's 81.5%. So it's closer to -1 than the -13%, closer to -100%. And so the latitude is a better predictor of the temperature in February. Okay, so let me just show you what I wrote down on here. And we'd say which is better. Latitude is a better predictor because it has a stronger correlation. Okay. All right, so we've decided latitude much better than the altitude. Okay, so for part B, it says New Orleans is at a latitude of 29.95, has an elevation of 1 meter. Use a linear model to predict the average temperature. And did we interpolate or did we extrapolate? Now, in part A, we've decided that latitude is a better predictor, so we want to use this one here, the 29.95. And I'm going to do this in the Excel file itself. So I have latitude in there right now, and I want to use 29.95 there, 29.95, and the prediction, that y hat, that is the prediction for the average temperature. So it's predicting 53 point, just about 53 degrees. Let's put that 53 degrees Fahrenheit. Okay, now did we extrapolate or did we interpolate? Well, 29.95 falls in between. It's bigger than this one. And look at the scattergram, it's a little bit easier. 29 is right here. So yeah, it's within the data, so we interpolated here, which is good. You want to interpolate versus extrapolate. Now the next one is similar, and I'll just read it and show you how to plug it in. It says Honolulu is at 21.32, latitude of 21.32, and has an elevation of 2 meters. And we want to use the linear model to predict the average temperature. We're going to use that 21.32 again instead of the 2 meters because latitude's a better predictor. 21.32. Plug that in. Gives us approximately 65 degrees. I'll write that down. Just getting it from here. And it has another question on here asking how good the prediction is. So it says it's given us if the average temperature in February is actually 73 degrees, what was the residual of our prediction? So it would be, we would take 73, let me say just right here, residual. Take that 73 and subtract the 65. And it gives us a residual of 8 degrees Fahrenheit. Okay, now I think we skipped a question. I just noticed here. Interpolate or extrapolate. And in this case, we actually did extrapolate because that 21.32 is lower than our smallest one here. Oh, it doesn't show me the point. There it is. 25.8 is the lowest. So 21 is over here. That would be extrapolating, which hopefully we remember extrapolation is not a good thing. Not a very far extrapolation, which is all right. But still it is extrapolation, which you do want to avoid. Okay, now the last one, part D, is telling us that the average temperature in February in Milwaukee is 26.3 degrees. And we want to use the model to predict the latitude. So it's giving us the opposite value. So the other two have been given us the x values, but it's now giving us a y value. So we plug that 26.3 in for the y coordinate over here in column L. And it's telling us that the prediction for the latitude is 48.54. Okay, then it also says in this one that the actual latitude is 43. Is actually 43. So it's the temperature there is predicting that it would be higher a higher latitude, so further north, than what it actually is. Because I should put the word predicted here. Okay. So this last page in the 4.3 notes is more of like a review page and to get you some experience with these conceptual questions, so kind of the questions that are on the first part of the exam, the ones that you have to remember. And this one is a little bit confusing. So we're looking at this. You gotta be careful with the way that these are worded. 2 data sets are given to a statistician, and she finds that the linear regression between the variables x1 and x1 and y1 produce a correlation coefficient of 91.34, negative 91.34%. And for x2, y2, that produces a correlation coefficient of 67.9%. Now, the first question is which one has a stronger correlation? And it's the one that's closer to 1 or negative 1, the one that the stronger correlation. So it would be x1 and y1. Since it's, I'm just going to put greater in absolute value. Absolute value of 91.34%, negative 91.34% is just 91.34%. Okay, now for this last one, we have to think about the relationship between the correlation coefficient and the slope of the line. And I'm just going to make a line in between these two. The first two, x1, y1, it has a negative correlation, so the line itself would go down from left to right. And then for x2 and y2, it has a positive correlation to 67.9%. So positive correlation would be a line going up from left to right. Okay, so for x1 increasing, so x1 going to the right, this way, the y1 was decreasing. X1 decreases, that's going from right to left. The y1 is increasing. Okay, now for this one, x2 increases left to right. It's going up for the y coordinate. It also increases. And then from right to left, y2 decreases.